Hi, I'm Kevin Dangoor, and I'm going to be talking about Khan Academy's journey from a big Python monolith to Go services. It's going to be a tale in three parts because I have a lot of stuff to cover, and I'm going to be talking about why we did it, how we did it in terms of the technology, and how we did it in terms of the project. And so that means I'm going to be talking about Python, Go, Google Cloud, GraphQL, code generators, and burn down charts. All of this in a 25-minute talk. So before I get into that, I do need to talk about what Khan Academy is because not everybody has seen our site. If you haven't, check it out. We are an education nonprofit. We have a mission to provide a free, world-class education to anyone, anywhere. We have many thousands of videos, articles, and exercises about a bunch of topics, and millions of learners come to us every month to learn on our site. So when we first started talking about this rewrite publicly, we did get some feedback with people wondering why we had so much code. Turns out there's a good reason. We have a lot of features, and people don't always see these features because they're not always target users of those features. So keeping track of learner progress is something every user sees because they'll see how far they've progressed in their skills and which skills they need to level up on. But we also have login with Clever and use with Google Classroom because working with classrooms is important to us because we are used as a supplemental resource in many classes already. We also provide reporting for school districts. We connect with the College Board for SAT prep. We have a content management system to manage all of that content that I was talking about, and also to work with translators who around the world who have translated Khan Academy to dozens of languages. So there is a whole bunch we have here, and that's why we have so much code. That's why our rewrite is not an easy project. So why did we have to do it? So to answer that question, we need to go back in time to 2010. And in 2010, Python 3 was still very new. It was actually less than a year and a half old. It was around a year and a half old, I think, at about the time of this commit that you see here. And that's that's not very old. Most of the libraries hadn't converted yet. There wasn't much available for Python 3. Plus, Google App Engine was also pretty new on the scene at the time. There wasn't much in the way of serverless architecture back then, providing both scalable web layer and scalable data layer, but App Engine provided that. And that stack actually served us really well. It did scale quite well as we added new users, as we added new features. That worked great for us. But the Python Software Foundation said January 1, 2020 was the end of life of Python 2. And so we knew we had to get off, we had to move, and we had to figure out what to do. To make matters more interesting for us, Google in August 2018 introduced App Engine 2nd generation. Now this was actually, I think, a really big improvement to App Engine because what it meant is that all of these bundled APIs that App Engine 1st generation offered have been unbundled in App Engine 2nd generation. So an App Engine 2nd generation app looks like any old web app, but you get to pick and choose which APIs you use from the whole suite of Google Cloud. It was a big improvement, but it also meant a lot of change for our code. Finally, I will mention that because we were running an App Engine monolith, that meant that all of our instances were running the same code. So if we wanted to be able to move to something else, including Python 3, that meant that we had to effectively adopt a services architecture, at least for one more service, which would be the new one. And that adds a whole lot of complexity to our system. And so we had to think about what kind of architecture we wanted to go forward to. And as we thought about it, we did some rough estimates, and we figured out that moving from Python 2 to Python 3 is a lot of work. Moving to a different language is probably going to be about 50% more work. So that's a significant amount, but we thought we could get significant benefits from doing it. Things like performance. We like some of the tooling available. Memory usage. All these things could be better, and runtime performance does matter a lot to us. So we looked at Python 3. We also looked at Kotlin, which we had some experience with, and we also looked at Go. And I probably don't need to convince you all that Go was a great choice for us. It has performed really well for us. The tooling has been great, and we're really happy with it. So Goliath is Khan Academy's project to move our entire backend to Go plus services. And we call the first 80% or so of the work our minimum viable experience. We took the most important of that called it our minimum viable experience, MVE, and you'll see this term later on. So now we can get into the tech. This is really cool. We got lots of stuff to talk about here. So the first part of our tech transition for this was finishing other technical transitions we had already started. We were early users of React, for example. We wanted to replace all of our Jinja templates in Python with React. So basically our Go backend was never going to generate HTML pages for the web. We wanted to get all of our service behind Fastly, which is a great CDN. We wanted to move all of our REST APIs as much as possible to GraphQL, which we had already started doing. So we had started these tech transitions and we wanted to complete them so we wouldn't have to port extra code over. And the same goes for, we had a 10-year-old product. We had some features that were outdated and not hardly used. So we wanted to reevaluate some of those. And so this is what our tech stack looked like, our architecture as of January 2020. We had a lot more dragons to worry about back then, but fundamentally our architecture was like this. This is a probably clearer and less fanciful picture of our architecture. But the general flow of a request is it starts in a browser or mobile app. It goes to the Fastly CDN, and from there, it's going to go to the render gateway if you're getting your initial page view, or if you're making a data request, it's going to go to the GraphQL gateway. That is colored yellow in this picture because it's JavaScript right now. It is Apollo server. And basically the GraphQL gateway is going to look at the GraphQL request and fan it out across all of the services. We have about 20 services right now. It's going to fan it out among those services, gather the data, and return it to the user. And that includes also calling the Python 2 monolith to get some of that data. So our Go services are all very consistent in structure. They all have, makefile and a README at the top. They all have a command package or command directory under which you'll find the package main for any binaries we want to build. It has some YAML files to configure some things. It's got some GraphQL files. It's got a resolvers directory, which I'll talk about, and a models directory for accessing our data store models. So let's get into GraphQL. I will give you a quick crash course in what GraphQL is like so that you can understand some of the architecture choices we've made. So first of all, we are looking at a piece of a GraphQL file here. And GraphQL lets you provide basically a typed API. So you define types. In this case, we're defining a type called user. And your types can have typed values on them, typed fields on them. And so basically KAID, CAID, is our identifier for a user, and it is a string. And you can also define directives, which provide metadata to the system about a given field or type. Next, let's take a look at a query. This is a query being defined on the server. So it's defining a query that can be run by the client. So a query, something the client can query for is a user. They can run a user query for, they have to pass in the CAID so they can identify which user they want, and they will get a user object back. Okay, and this is what a client-side query will look like. So it says query, you can name the query, you can pass in parameters to the query, and then you define what parts of the schema you want to pull out. So in this case, it's saying, hey, I want a user, and here is the CAID of that user, and you can specify exactly which pieces of data you want, so you're not going to overfetch. In this case, it's just saying, just give me the username, that's all I'm interested in. So queries are not allowed to change data. For that, you use mutations. They're defined just like queries, except it's under the mutation type, not under the query type. But they work exactly the same way. Otherwise, they can take in parameters and return values. But the difference is that they're going to mutate data on the server side. And so that's what's in the GraphQL files on the server. How do we get from these GraphQL files to the actual client, to actually serving something to the client? And that is where gqlgen comes in. So gqlgen is an open source project. It's great. It is a library and code generator that takes your GraphQL schemas and gives you type-safe APIs that you can use to implement a server that will respond to those GraphQL queries. Let's dig into how that works. So this is the package main for a service, for the serve command rather, and you can see that we're importing. We have our own little web framework, but our little web framework is basically just some conveniences around the standard net HTTP stuff that Go provides, but conveniences for our services. We're going to pull in the generated GraphQL code from gqlgen, and we're going to pull in our resolver code, and basically glue those together into an executable schema. And we use that schema to handle the GraphQL requests that come in. So that's what serve.main, serve.handle GraphQL passed into the schema. That's what it's doing. So if we jump into our resolvers and we look at what they're doing, the resolvers are basically gluing together GQLgen's generated GraphQL interface with our code that is going to be able to resolve the GraphQL data needed for responding to a query. So we're going to focus on this user resolver down at the bottom here. So again, that is an interface. GraphQL.userResolver is an interface that we are going to have to implement in our code in order to be able to respond to user queries. So this is a piece of the user resolver. Our user objects have actually a lot of data on them. And email is one of the fields that are on there. So for every field, you're going to see a resolver function like this that basically is, in this case, going to take a context and a user object, and it's going to return a string. It is a string pointer because it can be nil, and an error, so that basically every single field is going to look like this in the interface. So this is our handwritten code now that is designed to implement that interface. And this is what a lot of our resolvers are going to look something like what you see here. So basically, we are taking in the email, we're taking in the context in the user, just like we saw, just following the interface. We have our own dependency injection system where we basically upgrade a Go context to match up the interfaces that we need. So we have a nice typed interface that gives us access to all of the services that we need within a service. So for example, when we need to access data store, we just have to include that interface in here, and we will get the data store interface back. So the next thing that we need to do after we've got our context upgraded is we need to basically validate that the user making this request has access to this field. And so, yeah, so this is actually happening at a field by field level. That we can determine what permissions somebody has access to. And so in this case, not everybody has access to a user's email. This is definitely not open. And so we look at what's required for that access. So the next thing is that we're going to actually pull from our data model what the user object looks like in the data. And we get that by the KAID. Every single field, again, is going to look like this, which means that get by KAID function is going to cache that for the request. Is going to cache that user. This is how we make sure that we're not every single time for every single field pulling in that user object, because we just cache it. It's very simple. But the pattern is going to be very similar each time. We have this nice little PTR package that lets you do mappings from simple types to basically pointer types, because in this case, as we noticed from the interface, it can be nil, so it's a string pointer, and so we just have a convenience function to basically say, hey, if this is nil, just return a nil for it. Yeah, and so one of the things also I'll note is that email is personally identifiable information, PII, and so we make that very clear in our interfaces, and we also encrypt that data on our backend. So we have to decrypt it at the time that we know that everything is authorized. All right, and so that is what an individual service looks like. Now, some of the magic that made this whole transition work really well for us is GraphQL federation. And basically the idea with federation is that the query comes into the GraphQL gateway, and that is going to federate out the query to all the different services. So basically the GraphQL gateway has to take the schemas of all of those services, including our old Python monolith, glue them together into one big schema. That is what is served up to the users. So let's take a look into how federation works. Okay, so this query here is run by the assignment service. Okay, so this is actually a service-to-service query, but this query could just as easily be run on the client side. But the idea with this query here is that we are going to query data, and so we are calling that user query, so that same user query that we saw previously, we are calling for a user, and we're passing in the user's KAID because we know that that's what's required. But what we're requesting on user is student list. Now, what's interesting about student list is that is effectively a class in our system. And the student list data is presented by the coaches service. So the previous service we were looking at was actually the user service. This is something that comes from the coaches service. So how does that work? So this is how that works. This is from a GraphQL file in the coaches service. And you can see that it is saying extend type user. So the user type is defined over in the user service. The coaches service is saying, hey, let's extend that type and add, and that extension is based on the key of CADE. That's how it kind of glues users together between services, is it uses that CADE field to say, okay, give me this user's data. And it's going to say then, okay, I am providing on the user type student list. And I take in a student list ID, which is basically a classroom ID, and I return a student list object. And so the GraphQL gateway is going to have to stitch that together when somebody asks for a student list. So if you're asking for some fields of user, they will come from the user service. Asking for other fields, it's going to come from like the coaches service in this case. Now, one really cool feature that we got out of this is that we were able to make the GraphQL gateway do side-by-side testing. So what this means is that once we have an implementation in Go of the same field that's in Python, what we can do is have the GraphQL gateway request the data from both services simultaneously and return the Python data to the user, but compare the result. And if there's any difference in the result, it's going to log that. So we're able to look up in the logs, hey, are there differences that we're seeing? And if so, then we know, oh, we still have some work to do to make these match up. But the great thing is that this is working with real production data, and so all the weird little edge cases that have built up over the years are all going to be covered by this testing. Works out really well, and we can also prove out performance this way because we can make sure that the Go implementation is actually performing as well as we expect it to. So how does side-by-side testing work? In this case, we have a field that is implemented, or rather a type. The teacher campaign type is provided by the Python monolith still, but this field, the live field, comes from the campaign service. The campaign service, actually both campaigns and Python are both defining the live field. The difference is that this campaign service is saying we are migrating, that's what this directive is for, at migrate. We're migrating from Python to, and the current state is side by side. So basically what that means is it's going to tell the gateway, hey, when you look at this live field, we know that it's coming from the Python service, but we're doing side-by-side testing right now. And so that means that the gateway is going to run the side-by-side test that I just described. Once we're done with that and everything's happy, we can just change that state to migrated, and that will mean that the gateway will only send the traffic to the new Go service. Once we're completely done with it, we just remove the migrate directive entirely and we delete the Python code, and that's all set. So that gives us the ability to migrate even a single field, which is as incremental a migration as you can possibly imagine. So having talked about side-by-side testing, I wanted to come back and talk about this query that we looked at before that the assignment service is going to run to get data from the coaches service ultimately. I want to put this in more context. So in context, it looks like this, because in context, that query is living in a Go file in a string with this special @genqlient comment in there. And so that lets me introduce genqlient. So genqlient is really cool. This is an open source project that we've created. And what's great about this package is that it's very much like GQLgen for clients. It lets you create queries, generate type-safe Go code that you can then use to run queries from Go. So basically that query was defined and that string is more or less thrown away because genqlient turns it into the API you see here. We call the genqlient.getClassroom icon URL for assignments, and it takes in all those same parameters that you'd expect, and that's generated code. And the result that comes back, you can see there's response.teacher.classroom.id. So that is what the response is showing us, and it's all nicely typed, and it's also matched up when genqlient pulls this query out of our code. It's going to match up this query with the schema. So we actually get type-safe querying all the way through from our Go code all the way through to the GraphQL schema and the service on the other side. So that's pretty great. Basically, it's like if student list changes on the coaches service, we will know about it right away because our genqlient code here will fail to build. So I didn't have time to get into our test code, our data store models, library code, custom linters. We had a lot of really cool stuff that we've used to get us through this project and to put us in a good place with our Go infrastructure. But yeah, so far the experience of writing Go has been great. We love the tooling that we're using and the awesome production performance. It's been really great. So I want to talk a little bit about delivering this project on time. How did we do this project? So Goliath MVE, basically a little timeline. It was March 2019 when we made the decision that we're going to go with Go and services in this project. We had spent the rest of 2019 basically building early infrastructure and the first service to kind of prove it out. We had an overall idea of what the services would look like. And then spring 2020 is when the team really ramped up, when we really had like full staffing on the project. And we completed it at the end of August 2021. What is MVE? MVE ended up being about 85% of our GraphQL fields, which is about 5,000 fields, 95% of the requests going to the new Go backend, 750,000 plus lines of Go code. So we wrote a lot of code, did a lot of porting, and got it working. So our earliest estimates showed us coming in at May 2021. This is our burn down chart from Goliath MVE. By July 2020, we had a really good sense of what our velocity was looking like, where we thought it was going to go over time. And so we basically just managed the project diligently to keep things on track. People were very flexible. The engineers were flexible in moving to other parts of the project if other parts of the project needed some additional help to keep it moving on track. And you can see that we had a pretty smooth burn down. Or organizationally, we value working sustainably. And so I see this as a sign of consistent delivery and not a death march. Like we were just working it, and everybody worked really hard to get it through, but we worked sustainably and consistently. One of the things we did at the beginning of the project was we established project principles. These project principles also help to keep us on track. We clearly didn't want new Python features because new Python features would basically just add more to what we needed to port. So that wouldn't be good. A lot of the other principles are actually focused on keeping us from adding more to Goliath. When we're rewriting the code, we wanted to do as close to a straight port as we could. And so that's what a lot of these principles were trying to keep us on track for. So as of today, the last 15% of the GraphQL fields remain, so Goliath continues, but now it's just one project among several because we have a very comfortable move on our architecture, everything's running, and we're happy with where we are. And I'll just close with, I like Go more the more I work with it, which one of our Khan Academy engineers said, and that's a sentiment shared by many. Thank you all to the community for making it so great. And thank you for listening to my talk. If you have any questions, talk to me in the GopherCon Discord or hit me up on Twitter. I'm at Dangoor there. And if you're interested in working on this kind of project, go to khanacademy.org/careers.